All right, hello everybody. This is day one of digital learning. Hopefully the screencast video works well for everybody. Just before we get started here, the videos that I am going to be creating have a maximum time of 15 minutes. So as we work through over the next couple weeks, any lessons that will take longer than that, I may have to split it up into part one and part two. Today there's only 4 examples, so it shouldn't take that long. I think I should be able to get through it all in one video, but we shall see. Before we left, we went through all of quadratics in terms of solving quadratics, graphing quadratics, whether it's in vertex form or standard form. The main thing for today is that you have the understanding that the graph of a quadratic, whether it is in vertex form or standard form, will look like a parabola. In both cases, the vertex for this one, if it opens up, a has got to be greater than 0. And if it opens downward, a has got to be less than 0. The vertex here and here, if it's a parabola that opens upward, the vertex is a minimum value of the graph. And the vertex, if it opens downward, is a maximum value of the graph. So the whole point of today is when we're in word problems is if we can get any situation that we're trying to maximize or minimize, whether it's maximizing the profit of something or minimizing the cost or maximizing area, as long as we can get that in terms of a quadratic function, all we have to do is find the vertex of that function to figure out what the maximum or minimum is. Okay? So the first example that we're going to deal with is a rectangular garden that's wrapped around a house. So reading this off, the rectangular garden is to be enclosed on 3 sides by fencing, and the 4th side of the garden is a house. So what that will look like is this. I have a house here, and we'll say a rectangular garden that looks like so. So I have 2 sides that are the same length and 1 longer side. And again, that 4th side here is just going to be the house. So we only need those 3 to create this garden. The next sentence here, it's actually missing a word. It's the largest garden area that could be enclosed by 30 feet of fencing. So in this case, fencing, when we're talking about putting a fence around, that is basically just perimeter. So if I have 30 feet of fencing, I know that that is going to be created by these 2 sides and this 1 longer side of fencing. So it's going to be 2x plus y. Now, the main part of any max and min word problem is to try and understand and have a concept of what it is that you're trying to maximize or minimize. In this particular example, what we want to do is maximize the area. So for a rectangular shape, when we're talking about area is just going to equal length times width, or x times y. Okay? Now, in this case, so notice I have a system. I have a system of equations. I have one that was for my perimeter, one was the one that was for my area. Whatever you are trying to maximize or minimize, that is the equation that you want to work with. So what I mean by that, in this case, instead of, I have 2 options. I could either solve the area one for x or y and plug it into the perimeter one, or I could solve the perimeter one and plug it into the area. Since we are trying to maximize area, we want to end up using that area formula. Okay? So what I'm going to do here is first take this perimeter equation and I will solve that for y. So it's going to be y equals 30 minus 2x. And then simply take that 30 minus 2x and plug that right in to this y, which will give me area equals, I'm just going to rewrite this in order. First is going to give me negative 2x squared plus 30x. So this is a quadratic function. Instead of seeing y equals ax squared plus bx plus c, now I have a equals negative 2x squared plus 30x. So instead of having, an x comma y, in this case, I have x comma a for area. all right? Now notice that my leading coefficient here is a negative. So in terms of the graph of this, since my leading coefficient is negative, I know it's going to be a quadratic that opens downward. Well, the vertex of that quadratic is the maximum value of that graph. And if I were to go ahead and find the vertex of that, normally when you do the opposite of b over 2a, it gives you this value, the x value of the vertex. So I'm going to get x. And then after you find that value for the opposite of b over 2a, normally we just plug that right back into the equation and solve. In most cases it's solved for y, but in this case I'm solving for a. So when I find my vertex here, what I get is the x value of where that will maximize, and then what that actual area is for the maximum. So if I just go ahead and do that in this case, if I say, all right, the opposite of b times -2, which is going to give me -30 over -4, which is 7.5. So the x value where that happens is at 7.5. Okay? Now, what I need is, if I wanted to find what the actual largest area is, well, that's this a value of my vertex. So take the answer I got for x, plug that right back into my equation, and just simply solve that for a. So my area is 7.5 squared plus 30 times 7.5. And if you do that on your calculator, you will get 112.5 square feet. So that will be the largest garden that I could possibly make with 30 feet of fencing. Okay? Next. If you throw a ball upward with a velocity of v meters per second, its height in meters above the ground after t seconds is given by h equals v times t minus 4.9 t squared. If the ball is thrown with an initial velocity of 30 meters per second, this formula then becomes h equals 30t minus 4.9 t squared. How many seconds will it take the ball to reach its highest point, and how high will it go? So if you think about this, if I have the height is equal to, I'm just going to rewrite this kind of in standard form here, 4.9 t squared plus 30t. So here, normally when we have y equals ax squared plus bx plus c, my vertex of that is some x comma y point. So it's this variable comma that variable. In this case, if I find the vertex of this time, and I simply find that by just doing the opposite of b over 2a. And then when I go in and find my other value of the vertex right here, notice that that variable that normally is a y in our other problems, in this case is h. So instead of finding x comma y, now I'm finding t for time and h for height. Now in this case it's easy because I'm given what the equation is. Right here, that is the equation. So if I want to go through and figure out how long it takes to reach its maximum height, that is basically saying what is the time where it is at its vertex. And then if I want to find how high it actually is, that's just okay, then find the height after that given time. All right? So here, notice that my a value is negative, so my t comma h, in this case, is going to give me the maximum point on this particular graph. So here, if I do that, again, it's all just what's the opposite of b over 2a. So this is going to give me -30 over 2 times -4.9. It's my a value. If I were to do that just on a calculator, you get roughly 3.06. Okay? So my vertex is going to be 3.06 comma something. To find out what that something is, I am just plugging 3.06 right in for my t value, plus 30 times 6. And for time purposes, if you were to go through and calculate all of that, you would get about 45.92 when you do that. So the height would be roughly 45.92 meters. So to answer the questions, it took 3 point reach its maximum height, and that maximum height was 45.9 meters high. Okay. Third one. I'm going to try and move here a little faster. We don't have much time. John has 2 dogs. He wants to make 2 pens so that each dog will have the same size pen and as much ground space as possible. If John has 200 meters of fencing and the pens are to be rectangular, what should the dimensions be? So first thing here is going to be a picture. So here is a rectangular pen, okay? So I have this big rectangle all the way through, and basically what I'm doing if I'm John is I have, here are the sides of the rectangle, and I'm just gonna put a divider right in the middle of that rectangle, which is gonna be the same length as the 2 sides of my rectangle, okay? And then this whole width, I'm gonna call Y on both sides, all right? So now, it's kind of just like the first one we did up top. If he has 200 meters of fencing, that's perimeter. Well, now in this case, if I think about all of the fencing I need 1, 2, 3 X's, and I need 2 bits of fencing that goes all the way across my longer sides, so 3X plus 2Y, that's got to equal the 200 meters of fencing. And then in this case, again, I want to have the biggest possible area for these dogs. So the area in this case is once again for the whole rectangle just going to be X times Y. And here I have a system again. Now, what am I trying to maximize? I want to maximize the area. So I'm going to take that area equation, solve the perimeter one either for X or Y, and then just plug it right into the area equation. So in terms of doing that, if I were to, I'm going to say take the perimeter one, I'm going to solve it for Y. So I'm going to say, in that case, it'll be Y equals, where am I? You know what? I'm going to solve it for X. I'm sorry. So I'm going to say, well, no, you know what? Little. We'll solve for Y. So I'm going to subtract 3X over plus 200 equals 2Y, and then divide everything by 2. So I'm going to get Y equals negative 3 halves X plus 100. And then I can go ahead and take that and plug it right, whoa. I'm going to take that here and plug it right in for that Y. That area equals X times negative 3 halves X plus 100. Area equals negative 3 halves X squared plus 100X. Okay. And then again, here's all I need. I have my area equation. If I go through and find the vertex of this, it will tell me what that X value needs to be. And when I do the opposite of B over 2A, and then when I plug that back into X, that'll give me what, okay? When I do that, what I am getting here is an X value of, just to save time here, I believe I get 25 for X when I do the opposite of B over 2A. And then I am going to get, when I plug that back in to find my area, I'm going to get 1,666 and 2/3 for my area. So this would be the maximum area. I'm going to have to do number 4 on a different video. All right, so I will be right back with part 2